I was on mute the entire time, guys. Oh my God, I was on mute. So I'm gonna have to re-record most of this, okay? But I'm gonna go ahead and finish this part and I will go ahead and record over the previous section. That was at least 15 minutes of me speaking without it recording. Shazam, but at least I figured out the issue, guys. So let me go ahead and continue with this, guys. So I just found the missing side of this right triangle. Given cosecant of theta was 21 over 11, the 21 is the hypotenuse. Of course, one of the sides is 11, the other side is 8 radical 5. Now we're going to calculate the 6 trig ratios. So here they are, guys. We're going to start with sine. And of course, sine, remember, is the opposite over the hypotenuse. And so the sine of the angle is going to be 11 over 21. Now we're going to move on to cosine of the angle. That's supposed to be theta, guys. I don't know why my pen is not right. There we go, okay? Cosine of the angle is going to be 8 radical 5 over 21. Tangent of the angle is going to be the opposite, 11 over 8 radical 5. But you got to simplify this, guys. You rationalize the denominator. So you're going to multiply both the numerator and denominator by radical 5. So you get 11 radical 5 over 8 times 5. And 8 times 5 is 40. All right. So we got those three. Now we're going to do the cosecant. Well, we have the cosecant already, so we're good. So now we're going to move to secant. Secant is the inverse of the cosine. So that's going to equal to 21 over 8 radical 5. We're going to multiply the numerator and denominator by radical 5 so we can rationalize the denominator. So we're going to end up with 21 radical 5 over 40. And I'm using, the tangent to help me get through that. And then last but not least, guys, cotangent, remember, is the inverse of pi. Since cotangent is the inverse of pi, this one's going to be inverse of tangent, inverse of pi, inverse of tangent, guys. So this one's going to be 8 radical 5 over 11. So guys, there's your 6 trig ratios for this one. They gave us one, we really just had to find 5 of them. And this is number 7 and assignment number 4. All right, guys. So let me finish this out by sharing some information about the unit circle, guys. I'm not going to go too much into it. I just want to keep adding little bits and pieces to it, okay? So guys, I am going to go to the XY plane. By the way, when we talk about the quadrants go in counterclockwise motion. So that's the first, this is the second, this is the third quadrant, and this is the fourth quadrant right here. If you were to graph a coordinate point in the first quadrant, both X and Y would be positive. In the second quadrant, X is negative, Y is positive. And the third quadrant, both X and Y are negative. And in the fourth quadrant, X is positive, Y is negative. Now I'm gonna try and draw a circle here, guys, okay? So, all right. Ooh, that might not be the best circle, guys, okay? So just work with me here. That's not gonna be very, ooh, Shazam. Slightly off, guys. Okay, so some of the things that I wanna mention here, guys. Once you set up the XY plane, guys, you create those 4 quadrants. Remember, the circle adds up to 360 degrees. So if you are going to divide it up into 4 quadrants, each quadrant will be equivalent to what? 90 degrees each. So the degree measure starts right here and moves counterclockwise. So over here, guys, along the positive side of the x-axis, this will reflect 0 degrees. And we're going to move counterclockwise. Every quarter we go, we're going to go 90 degrees. Every quarter, we're going to add another 90 degrees. So this would be 180, and everybody should know that. That's half of the circle. And over here, okay, that's going to be at 270, 90 degrees, okay? Now, additionally, we are going to convert these to radian measures. Remember, the circle, guys, has a total of 2 pi radian measures. So if you break it up into 4 units, when you simplify this, it's going to simplify to pi over 2. So again, starting at the positive side of the x-axis, we start over here with 0 radian, and we go a quarter turn. That's going to take us to pi over 2 radian. Go to 180, that's going to take us to pi radian. Go to 270, that's going to take us to pi plus 1/2. So that's going to give us 3 pi over 2 radian. And then once you get back, you've made your full circle, that's going to take you to 2 pi or 360 degrees, okay? I wanted to mention those things. Now, additionally, guys, okay, because we are moving, this is a unit circle. We refer to it as a unit circle. Now, remember, I mentioned this to you guys in another video. When we talk about a unit circle, the radius of the unit circle is 1. So guys, essentially, if we're traveling from here to here, this is going to be a distance of 1 unit. Let me use a different color here. That's 1 unit. Now, because we're traveling horizontally, okay, and that's the x value. Remember, I mentioned this to you guys before, x and y. Cosine is equivalent to x, and sine is equivalent to y. So over here, if I were to ask you what is, let me see, cosine of 0 degrees, cosine of 0 degrees would be equivalent to 1. Why? Because, guys, over here, I'm along the x-axis. I'm traveling 1 unit to the right, so this would be 1. I'm not moving vertically, so the y value would be 0. So if I were to ask you for sine of 0 degrees, guys, that would be equivalent to 0 because I'm not moving vertically. I'm staying right there on the x-axis. Now, let's move to the 90 degree, to the quarter. Okay, right here, guys, I'm moving vertically. Notice I'm moving vertically. So now the y value is going to be 1. However, there's no x value. So when I go over here, guys, and I ask you what is the cosine of 90 degrees, because I'm still at the origin, I'm not moving left, I'm not moving right, the cosine of 90 degrees will be 0. However, the sine of 90 degrees, because I'm traveling 1 unit up, that's a radius right there. That's 1 unit, guys. It's going to be equivalent to 1. All right. Now, we can also represent this as a coordinate point, guys. So let me see here if I can erase some of this so I can start writing the coordinate points in there for you. Okay, because it makes sense to have those coordinate points in there. So, all righty. Let's see if we could use this color right here. So at 0 degrees, guys, we're going to have 1, 0 as the coordinate point. At 90 degrees, it's going to be 0, 1. And then, of course, you can go around the circle. Now, be careful. When you get to 80 degrees, 180 degrees here, we're on the negative side of the x-axis, so the x value is going to be a negative. So over here, cosine of 180 degrees is going to be a -1, while the sine will remain at 0, okay? So this one right here, guys, is going to be -1, 0. And then, of course, you go down here to the 3 pi over 2. And so 3 pi over 2, we're on the negative side of the y-axis. So this means that the sine value is going to be a -1. So cosine, though, of 270 will be 0, while the sine will be -1. So the coordinate point down here will be 0, -1. Now, like I said, I'm giving it to you in bits and pieces because I don't want you guys to be overwhelmed. So I'm going to pause here. I am going to pause here with the unit circle and leave the rest for another day because this is an overwhelming amount of information. So I'm going to pause here. I'm going to have to re-record over the previous part of the video that did not have any sound. So guys, until next time, bye.